Hi everyone, Eitan Vosel here again. This is my second video on the Introductory to Mobb video series. If you haven't seen the first video where I gave an overview of Mobb, you should probably check it first and come back here. In this video, I will show you how you can quickly and efficiently fix many different static analysis reported findings on your application. So let's get started. I am going to fix my code with Mobb. This code was already scanned with check marks, so I'm going to pick check marks and I will upload the report that I already have on my file system. It was the WebGoat application. I'm uploading the report, and the next step is to point Mobb to the code that was actually scanned. Because I already authorized Mobb to get access to my GitHub, I can pick the repo from a list. If you haven't yet, you will see a different option here, or you can pick manually enter the URL. So I'm going to pick it from my list and WebGoat. This was the repo. I need to also make sure that I point Mobb to the exact code version that was scanned with checkmarks in this case. Otherwise, the indexes that we see in the report will not match the location of those vulnerabilities in your code. As the analysis starts, fixes will start pop up in here in the list. You can see the git hash of the code, and you can see the tool that was used to scan the application. Now we will wait a few seconds and we'll see the issues start piling up here. Quickly, you can see that Mobb identified the person that probably needs to fix this vulnerability, and I will soon explain to you how we identify that, and the confidence level that we give to a fix. You see, Mobb uses a mix of technologies, including static code analysis, deterministic application fix algorithms that we have developed, and some AI. And we are measuring those fixes and over time growing them. So if you see something that is marked as stable, you can trust that it is really, really good. So I'll pick one vulnerability and go in. As I mentioned, Mobb tells me who is the dev owner for this fix. And we identify this by looking at the first file, the first line that we need to change, and see who's the person that touched it last. What you can see here is the git-like diff component, where you can see the code before and after the fix. Naturally, the problem here is that someone, nbars here, wrote a code where it takes a vulnerability that, a parameter that came from the outside, concatenate it into a string, and then execute the query into the database, potentially introducing SQL injection. And the fix is to turn that to a prepared statement. On the left side, you see some question for you, the developer, that we need help with in order to make sure that our fix is correct. For example, when we look at this account name, we know it's a string in the code. So when we build our fix, we use the set string method. But maybe as the developer, you have access to your database. You know that in the database, account name is actually of type integer. So you will change it to type integer, and you'll see on the right side the code is being updated to reflect that. Once you finish answering all the questions, you have the option to apply these answers to all other questions. As you saw, we had more SQL injections reported here. So I can apply the answers from question 1 and question 2 to all the SQL injections if it makes sense. So if we see account name again, we will know it's a string and don't need to ask you again. One more thing that we can do from this point, exactly, we can download the patch to open in our IDE locally or commit locally to Git, or I can commit the changes directly from here and I can influence the settings here. I'll click commit changes, and what's going on here is that it's going to be pushed to my Git repo. As you can see here, comparing changes, and I can create the pull request. I'll go back and I want to show you yet another vulnerability that we have here. See, it's still being analyzed, more fixes are being piled up, and I want to show you this, for example, the server-side request forgery. So in order to fix SSRF, you need to give an approved allowed list of domains that you want the code to support. In this case, I will do mob.dev/mob.ai, and you can see the validate domains being updated automatically. And again, as before, I can apply this answer to any SSRF reported in my application, and I can commit the code. So I hope you found this video valuable, and go ahead and try it. Happy fixing, everyone.